Hi everybody, welcome to our lesson on the introductions to minerals. What we're going to concentrate on in today's lesson are the characteristics of minerals and also how they get classified. So let's get started. Now if you have an object and you wonder if it's a mineral, there are 5 characteristics that something must meet in order to be classified a mineral. The first characteristic we'll mention is that all minerals are solid. So this means that a mineral cannot exist in a gas or liquid state at any time. It must be solid at all times. Number 2, all minerals are naturally made or found in nature. If there is a mineral or something that looks like a mineral that's been made in a lab or some sort of controlled environment, then that's not going to be classified as a mineral because it wasn't made by nature. Now, there are a couple of ways that minerals are made in nature. If you take a look at the image here, you'll notice that we have a lava flow coming down a hill. And as that lava flows down the hill, you'll notice that there's a black film at the top of it. And that black film is actually rock starting to form. And the reason why the rock is starting to form is because the elements that were in the lava themselves started to cool and then crystallize to form minerals. And then those minerals became bonded to one another to form this rock. So if you take a look below, in the image below, you'll notice there's a piece of granite, which is a rock that's made when magma from inside the earth slowly cools. And if you notice on this picture of granite, you'll see that there's tan speckles, which is the mineral called feldspar. You'll notice that there's quartz, which is clear. And then also you can have biotite mica, which is the dark fragments or dark crystals in the rock. So that's one way minerals can form in nature. The second way minerals can form in nature is if you take a look at this picture here, we'll see salt ponds. And sometimes a salt, such as the mineral we have in the middle here, which is also known as halite, salt gets dissolved in water. And when that water evaporates, it'll leave the elements of sodium and chlorine behind, and they will combine together to form salt. So some minerals can form or through the process of evaporation. Now also, if you go to a beach such as Main Beach, you'll notice that the sand there at Main Beach is made up of a bunch of fragments. If you take a close look at the fragments like we have in this picture here, you'll notice that there's some pieces that are shell fragments, but you have other pieces or other fragments that are there because they are mineral fragments. And again, kind of similar to the granite that we talked about, the fragments that you'll see are the tans, which are feldspar again, quartz, which is the white or the clear, and then depending on where you are, the black could be biotite mica or a mineral called magnetite. So that's our second characteristic of minerals, that they are naturally made and also found in nature. Our third characteristic of minerals is that they are inorganic. Now, inorganic means that they are not products or not made of materials that were living or once living. Minerals have no form of plant or animal matter or are not created by processes done by plants or animals. So minerals are always inorganic. Next, minerals always have a definite chemical composition. So if we take a look at our mineral here called halite, again, halite is made up of 2 elements. And if you take a look at this table of elements that you probably remember from 6th grade, you'll see that there's a ton of elements. There are some of these elements that combine with other elements to form our minerals. As I said before, halite is made from sodium, which is Na, and Cl. Now, what it means to have a definite chemical composition is that this mineral halite has NaCl all throughout. That's all it's made out of. So anything with a definite chemical composition is made from the same materials all throughout the crystal. And the word crystal brings us up to our last characteristic. All minerals must have a crystalline structure. Now, what a crystalline structure means is that the atoms inside of the mineral must have a repeating pattern. So if we take a look at this picture of an NaCl atomic structure illustration, again the structure of the salt that we have here, you'll notice that there's a repeating pattern of chlorine, the Cl, and Na, the sodium. And if you take a look at the picture, you'll see that the greens and the purples always alternate. So depending on where you are, there's always a green chlorine followed by purple sodium, then followed by another green chlorine, and then branching off that chlorine could be sodiums in any direction. So when you take a look at it, those atoms arrange themselves into a specific crystal pattern and thus giving the mineral its crystal shape. So if you look at this illustration here, you'll notice that the halite atomic structure illustration is cubical. And if you look at the picture in the middle, you'll notice that Halite is naturally cubical, and that's because of the arrangement of the atoms inside the crystalline structure. In order to be classified as a mineral, let's recap really quickly. A mineral must be solid, it must be naturally made and found in nature, they have to be inorganic and have a definite chemical composition, which will ultimately give it a crystalline structure. So those are the 5 characteristics for minerals. Now let's take a look at the 2 major categories of minerals. Okay, now minerals can be separated into 2 major categories. They are called silicate minerals and also non-silicate minerals. So let's take a look at the differences between the two. Now, the main difference between a silicate mineral and a non-silicate mineral is the presence of 2 elements. Number 1, silicate minerals. Silicate minerals contain both silicon and oxygen. So in order to be a silicate mineral, it must have those 2 elements inside of it. Not one or the other, but it needs to have both. Since silicate minerals have both silicon and oxygen, then you could probably just imagine what a non-silicate mineral would have. A non-silicate mineral can have either silicon or oxygen, or perhaps not even any one of those 2, but they cannot have both of those elements in there. So if we take a look at this chart, the Regents Earth Science reference table, we can take a look at a bunch of these minerals and see and determine what type of mineral they are based on their chemical composition. Let's take a look at a silicate mineral down here at the bottom, or a couple on this chart. One, we have quartz, which is Si, which stands for silicon, and O2, which stands for oxygen. And quartz is a mineral that's found inside your watches that can power the watch. It can be part of jewelry, or typically if someone buys a geode, one of those hollow rocks that have crystals on the inside, usually it's quartz minerals in there. So quartz is a silicate because it has the formula of SiO2. Also, if we take a look at the mineral talc, the mineral talc is up here and it can be found in ceramics and paper, but also talcum powder, which is also known as baby powder. So talc, the main component of baby powder, is a silicate mineral because if you take a look at its chemical composition, as magnesium, silicon, and oxygen in that again. So the combination of silicon and oxygen makes it a silicate mineral. Now, if we take a look at some non-silicate minerals, one example of a non-silicate mineral that you use every day is called graphite. Graphite is the stuff at the end of your pencil. That's what we call quote-unquote pencil lead, although it's not lead. Now, if you take a look at graphite, graphite is made up of carbon and only carbon. So there's no silicon and oxygen in there. So that's non-silicate. If you take a look at the mineral selenite gypsum, this is all over your house. You have it in your walls because it's what makes up the drywall or the sheetrock that is attached to the studs in your house. And if we take a look at the chemical composition, as calcium, sulfur, and oxygen, S stands for sulfur, not silicone, and 2 waters. So if we take a look, there is no combination of silicone and oxygen, even though it does have oxygen, because there's no other silicone in there, it makes it a non-silicate mineral. And another example of a non-silicate mineral is the one we've been talking about the whole time. It's a mineral called halite. Halite is also known as salt. So this is the mineral that you put on your food, what makes pretzels and potato chips taste so amazing. And if we take a look at halite's chemical composition, it's NaCl, sodium and chlorine. So it has neither silicone or oxygen in it. So it makes it a non-silicate mineral. All right, so those are some examples of silicate and non-silicate minerals, and that's how you're able to determine the difference between the two if you can see the chemical composition of them. And then the last major difference between the 2 categories is this. Silicate minerals make up most of the Earth's crust, or the most abundant minerals in the Earth's crust, and we'll learn that the Earth's crust is the outer shell of the Earth that we walk on. And non-silicate minerals, not so much. They're not as abundant as silicate minerals are. Okay, well that concludes our lesson on our introduction to minerals, the 5 characteristics of them, and the 2 major categories of them. I hope you found that helpful.